In this video, I'll be talking about AC voltage and current properties. And AC voltage just means that it varies with a sine wave, or it's sinusoidal. So the relationship that I'm going to explain for a lot of this, such as Vrms, is kind of like the equivalent voltage or current from a sinusoidal influenced voltage or current that would be similar to if it were a DC or a constant. So this is kind of the equation that I like to think about, and this would be the voltage that it's producing is just a constant voltage that is influenced by the sine wave, the time, and the angle, or something from the sinusoidal wave that's going to influence it, or the frequency, or omega in this case. So this is just the voltage based on the voltage that it would be producing, but it's influenced now by time and by a sinusoidal wave. So the first thing to introduce with this is phasors. So phasor voltage or phasor current is shown by a bold, in this case I did bubble letters, V or I, and we find this by taking Vrms, or sorry, we don't find this by Vrms. It's shown as Vrms angle, and then the angle that it would be given at. Then we have IRMS angle at the angle it would be given at. And this is always constant, or is taken from this same measurements, or taken from the same equation that we may find that is given to us in an equation. So the way that we actually find Vrms or IRMS is from this equation. I or Vrms is equal to I or V0 over the square root of 2. If you're finding Vrms, you use V, or if you're using IRMS, you use I of 0. That's the equation. You can also go the other way around if you switch these around. If you have Vrms, you can do Vrms times the square root of 2 equals V of 0. I'll write that real quick. That would be if you have Vrms and you want to go the other way, if you're looking to go from Vrms to this equation. And one other thing that I want to know about this equation is if you aren't given omega, you can actually find it. Or if you're given the frequency, you can actually find omega. That will be the case in some problems. Otherwise, if it's given to you like this, you can usually just take the same W or solve it using this equation. So a lot of equations to take into it at first, but this is simply relating the voltage or the current from a DC circuit, and it's now showing it as it's affected by sine wave or by the time that it's taking. You have phasors, Vrms, this equation to relate phasors with your normal voltage or current that you're given at an angle, and this would be the equation that helps relate those all.